Hi everyone, welcome to workshop number 2 of your Planted Goodness workshops. Today we're going to be talking about greenhouse gas emissions, and we're going to talk about how that relates to climate change and also how that relates to the overproduction of livestock. We're also going to be discussing no-till farming, which is one of the principles of regenerative agriculture, or a more sustainable way of farming that keeps carbon in the soil rather than exposing and degrading the soil. So first, we'll talk about greenhouse gases, which are the heaters of our planet. On the left, you'll see a bunch of different sources of greenhouse gas emissions, including electricity and heat, agriculture and land, industry, transportation, other energy, food waste, and buildings. So try to think about what are some ways we've already addressed these sources, because we have technology that has allowed humans to reduce their emissions in some of these sections already. So what do you think about that? You can pause this video a minute to think about it or discuss. One of the ways is through renewable energy sources, such as wind or solar power, as you can see in the picture, because it doesn't rely on fossil fuels, so it doesn't generate as many emissions. We've also, you can't see, it's under my face, but started with electric vehicles, which reduces the emissions in the transportation sector because electric vehicles don't release as many emissions as gas-powered vehicles. And finally, we've also reduced our plastic usage, which cuts down on the emissions from the industry sector. So in what category is food? I mean, I see food waste and maybe agriculture and land, but I don't really see a sector that has food or is dedicated towards food or where livestock would fall. So what category do you think food is in? Take a moment to discuss this. Well, food is actually in all of the categories. It's in farming, processing, electricity and power for the factories, transportation, and food waste. We'll get into all of these later, but in every step of the food production process, it releases emissions. If you think about it, I mean, let's say buildings. That doesn't really seem like it relates to food, but think about all of the buildings or factories that are used to house the food when it's being processed or where it goes to be packaged and shipped. And electricity and heat. The food needs to be refrigerated a lot of times. That takes a lot of electricity. Or sometimes, like, the feedlots are air conditioned and they have to use electricity to generate that too. And one note is that we can control what we choose to eat. So we don't have to wait for new technology as we did for the other solutions to these greenhouse gas emissions, like electric vehicles or renewable energy sources. We don't have to wait for new technology. We choose what we eat, and we have power over this solution to the food category of emissions. So let's talk about the greenhouse gas effect. What are greenhouse gases? Well, they're gases in Earth's atmosphere that trap heat. Although some are human-made, many would be naturally released even if humans didn't exist on the planet. So say like at the time of the dinosaurs, greenhouse gases were still in the atmosphere because they were released by natural things like volcanoes. So think of a greenhouse. They have glass walls and a roof. So it stays warm inside. The glass allows the sunlight to come in, but then it traps it so the heat stays in. So during the day, the sunlight shines in, and at night, the sun's heat stays inside. So the greenhouse stays warm. So think of the atmosphere as Earth's blanket. On a very cold night, just a sheet would be very cold. So the more blankets you get, the warmer you get. The gases similarly act as a blanket and add to Earth's atmosphere because they keep trapping heat inside the Earth. So without these gases, Earth would be very, very cold. So overall, greenhouse gases are a good thing because they keep us warm and comfortable. However, there's too many greenhouse gases in the atmosphere right now. Humans are adding a lot more of these greenhouse gas emissions to the atmosphere. Humans are pulling carbon dioxide and methane from the ground and putting it in the atmosphere very, very quickly. It's too quickly for ecosystems and animals and other species to adapt because earth the earth's atmosphere is getting so many greenhouse gases in it that it's just trapping so much heat, and the earth is just warming like crazy. This is what is known as global warming. So let's meet some of the greenhouse gases and see what they do and what they are. So we're going to do an activity. Take out your Building Greenhouse Gas Models worksheet. For this activity, you'll need some gumdrops and a toothpick because you're going to build your greenhouse gas models. You can pause the video right here to start getting all of the materials you need. And as I go through each greenhouse gas, you can start building your models because I'm going to tell you a little bit more about each one. So there are 6 main greenhouse gases, but we're really going to focus on 3: carbon dioxide, nitrous oxide, and methane. There are also other greenhouse gases such as ozone, water vapor, and chlorofluorocarbons, but we're not going to focus on those as much because carbon dioxide, nitrous oxide, and methane are the main greenhouse gases, especially when it comes to the production of livestock. Okay, so you can start building your model for your carbon dioxide now. You can look at your activity sheet if you need help or you want to learn more about carbon dioxide. I'm going to start talking a little bit about it right now. So carbon dioxide's all around us. We exhale it. Plants inhale it and give us oxygen from it. It comes from decaying and living organisms, and when fossil fuels are burned, this is what's released into the atmosphere. So this is primarily what's released from those like buildings and industry that we saw. And when you see that those pictures of like the fumes coming out, it's mostly carbon dioxide. So livestock is responsible for 9% of global carbon dioxide emissions. And this is mostly from the expansion of land for feed and livestock. Because in order to expand land to house the feed for the animals and the livestock, farms have to cut down rainforests and other natural land sources, and that releases a lot of carbon dioxide. So a GWP is known as the global warming potential, and carbon dioxide is used as a standard. So basically the GWP of carbon dioxide would be 1. It means if you had a certain weight of carbon dioxide and heated it up, this is its heat capacity. This is the amount of heat it would hold. So now we're going to talk about methane. Methane is released from wetlands, raising cattle, burning natural gases, and burning coal. It traps a lot of heat. It has a GWP of 36. So we said carbon dioxide has a GWP of 1. Methane traps heat 36 times more effectively than carbon dioxide, which means it's 36 times as dangerous if we get too much of it in the atmosphere. It also breaks down more quickly than carbon dioxide, so it starts heating the atmosphere, or it starts trapping heat a lot more quickly. Livestock is responsible for 37% of human-caused methane emissions, which is mainly from manure and their digestion process, which we'll talk about later. And finally, nitrous oxide. So much of nitrous oxide results from the natural nitrogen cycle, which is okay. Bacteria in the ocean and in soil can make it, and it's also released by fertilizers, power plants, and factories. This is where it's released the most when it comes to livestock production, because in order to produce feed crops for the livestock, farmers have to use a lot of fertilizer to grow a lot of crops really quickly. So livestock is responsible for 65% of human-caused nitrous oxide emissions. That's more than half of all of the nitrous oxide emissions that humans create. And again, this is mainly from fertilizer and the factory processing of meat. I also want you to note that nitrous oxide has a GWP of 296. So methane had a GWP of 36. This one's 296 times as effective as carbon at trapping heat in the atmosphere. So that means if we get too much of this one, it'll be a serious problem. Okay, so let's see how meat and the greenhouse gases relate because they seem kind of Unrelated. I mean, one's gas and then livestock is just there. So, livestock is actually responsible for 18% of global greenhouse gas emissions, which doesn't really seem like that much, but if you think about it, this is equal to about all of the emissions from transportation combined. This includes all of the methods of transportation you see on this slide: helicopters, airplanes, cars, trains, and boats. So, livestock produce about as many emissions as all of these things combined. So we're going to do another activity with your greenhouse gas models that you just created. Remember that breakdown that you see on the left of greenhouse gas emissions? We're going to investigate what greenhouse gases are emitted at each stage in the production of meat to show you how food is really in all of those sections of greenhouse gas emissions. It doesn't really fall under one. For each slide, there will be a stage in the meat production process. Guess which of the three greenhouse gases are emitted during this process. It can be more than one, so sometimes it could be all three. Hold up your candy models of carbon dioxide, methane, and or nitrous oxide to show your guess, and then see how many you can get correct. Let's get started. So, first stage, the production of the meat. So in order to produce enough meat, they have to destroy forests, wetlands, and other carbon-rich places because, as we said, they need room to either put the livestock or grow the feed crops, which they will eventually feed to the livestock. So hold up the greenhouse gases you think are released. You can pause at any time if you need more time to think or discuss. I'm just going to go through this pretty quickly. Yes, all three greenhouse gases are released during this: carbon dioxide, methane, and nitrous oxide. This is a big, this step in the process is a big releaser of a bunch of greenhouse gas emissions. Next, we have producing fertilizer and chemical inputs, including pesticides, growth hormones, and antibiotics. What greenhouse gases do you think are released here? Mainly carbon dioxide and nitrous oxide. Raising feed crops for the livestock. What greenhouse gases do you think are released? Mainly carbon dioxide and nitrous oxide. How about fueling farm machinery and irrigation systems? So this takes a lot of energy and sometimes electricity, and sometimes farm machinery uses fossil fuels like gas or diesel. Yep, mainly carbon dioxide. And then how about degrading soil and fertilizer use? Because as we talked about, when you overuse fertilizer, it makes the soil unhealthy. This is all of the greenhouse gases because when you make the soil unhealthy, it can't store as many greenhouse gases in the soil, so it ends up releasing it. Enteric fermentation. This is a big word, so we'll talk about what this is in a second. Mainly methane is released through enteric fermentation, and it's because enteric fermentation is part of the digestion of um, livestock. So, one myth is that cows produce the most methane from their farts. That's actually not true. Cows produce about 90% of their methane through enteric fermentation, which is actually not through the farts. It's on the other side of the cow. It's through their mouths, it's through burping. So cows are ruminants, which are animals that digest through enteric fermentation. So enteric fermentation allows ruminants to turn grass into protein, which is something that a lot of people can't do. I mean, a lot of species can't do. Humans cannot do this. So cows actually have four stomachs. The food is broken down in the first stomach. And then cows spit out the broken food and re-chew it. That's why you see cows chewing all the time, because they spit out their food into their mouths and then re-chew it. This creates a lot of methane and creates a lot of burping from the cows, which uh, leads to the releasing of methane. Okay, continuing on with the little game we were playing. What about waste management? This is referring to how they deal with all of the waste that is created by the livestock, because livestock create a lot more waste than humans do. Yeah, this releases methane and nitrous oxide. Okay, stage two, processing the meat. So cooking, cooling, packaging, and processing the meat. So this is getting basically the meat from the farm and now looking a little bit more like the thing you buy at the grocery store. Yep, mostly carbon dioxide because these are usually processed in the buildings and use a lot of fossil fuels. Stage three, distribution and consumption. Transporting, refrigerating, lighting at supermarkets, preparing, and cooking. Yep, this is mostly carbon dioxide as well. And finally, waste. So this is referring not to the animal's waste, but to the food waste because we don't eat all of the food. We usually have a lot of food waste. So this means disposing of the waste, composting, anaerobic digestion, which just means without oxygen, and incineration. Yep, this releases all of the greenhouse gases, carbon dioxide, methane, and nitrous oxide. So here's a challenge. If you were going to try to solve the problem of too many greenhouse gas emissions being released from the production of meat, where would you start? I mean, there were so many stages in the process of the production of meat. You can't address them all at once. Where would you start by addressing? Hint: try to think of the one that releases the most greenhouse gases. Not necessarily just all of the greenhouse gases, but just releases like the most in quantity. So think about this and maybe discuss it for a little bit. So I would start with the step one in the process would be destroying forests, wetlands, and other carbon-rich places. Because as it says on the screen, these places are full of carbon. So when they're destroyed and when they're taken down, all of that carbon is released into the atmosphere along with other greenhouse gases. And forests and wetlands, especially forests, they have so many trees which take in carbon dioxide and release oxygen. So they're actually helping us fight climate change. So when they're destroyed, they can't do that anymore. Another step that produces a lot of greenhouse gases is the enteric fermentation and manure, which produces a lot of methane, as we saw. Because there are so many cows and livestock, this is a huge producer of greenhouse gases in the process because there's just so many of them that have to go through their digestion process. So how we can help? Eating more plant-based. We can eat more plant-based and help reduce a lot of these emissions because red meat creates about 10 to 40 times the greenhouse gas emissions as vegetables and grains. So imagine just eating more vegetables, grains, fruits in your life, and you can just reduce your emissions almost instantly. And there's also the sustainability aspect. Eating more plant-based will help us reduce our emissions so that we can eat meat in a sustainable way that our environment can support. So it's about sustainability, not elimination. We don't have to cut out all of the meat in our diets because that that seems scary and big and like impractical for a lot of us. We just have to reduce our intake of meat so that not as many livestock are being produced and like as we said, the enteric fermentation, it creates a lot of greenhouse gas emissions just because of the quantity of livestock. So if we just ate meat less and ate more fruits and veggies more often, we could reduce the demand for meat and they would start producing meat in a more sustainable way that our lands can handle. Because cows can be on the land. They're naturally part of the land, and that's fine. We just put way too many cows on one piece of land now. So we just have to get it back to where nature can restore and have its own balance. So in the UK, if everyone ate one plant-based meal a week, just one plant-based meal a week, emissions could go down by 8%. So even if you just, every Sunday you have a plant-based breakfast, some like plant-based pancakes and some granola, emissions could go down by 8%. That's a lot for just one plant-based meal a week. In the US, if everyone replaced chicken with a plant-based food for one meal a week, carbon dioxide savings would be equal to taking 500,000 cars off the road. So you always hear how transportation and cars create so many emissions. That's why everyone's switching to hybrid or electric vehicles, which is great. But just imagine what we could do if we all just replaced chicken for one meal a week. That is a big difference, and that can make big changes. A global switch to a more plant-based diet could reduce greenhouse gas emissions by 2/3. That is a lot. Okay, and now we're going to talk about regenerative agriculture, which is the other side. So we talked about how a lot of emissions are produced during the production of livestock, especially during the farming stages. So regenerative agriculture presents another way of farming, which is more sustainable and restorative to the land. And we're going to talk about one aspect of that today, which is minimum disturbance of soil or no tilling. So let's think about, what is a plow? What do you know about a plow? Well, they've been used since basically the beginning of history. They till and break up the soil. Tilling just means preparing the soil for crops by digging, shoveling, and turning. They also help bury crop residues, which are the just leftovers after farmers harvest the actual crop, and they help control weeds. So why is the plow bad? I mean, it seems like a good thing. We've been using it since basically the beginning of history, so it must work. Well, one of the reasons is because it leads to soil erosion, because when you turn the soil with a plow, it makes the land more susceptible to erosion and rain, which destroys the topsoil. It also uses a lot of fossil fuels because plows take diesel and gasoline to run. So when they burn those fossil fuels, they release a lot of greenhouse gases. And finally, they release carbon dioxide. Plowing causes the decomposition of material to speed up because of the turning and like exposing the soil to the air, which makes it release carbon into the atmosphere rather than storing carbon in the soil. So what does no-tilling do? Because that is what regenerative agriculture practices. So why is this better? Well, it leaves a lot healthier soil because it allows the soil to retain its nutrients and maintain its fertility. It also helps soil retain water because even intense rain can sink into the soil instead of running off, because if you keep turning the soil, it won't be able to absorb as much water. It also uses less resources because you don't have to pay for your gas bill or diesel because you don't need to use the plow anymore. And it also helps keep carbon in instead of releasing it, as we saw that the plow did. The world's soils can hold about twice as much carbon as the atmosphere, which is a lot more. And no-tilling helps keep the carbon in the soil rather than exposing the soil to the air and letting the carbon get released. So how does this relate to eating less meat? Well, it's another way we are working to address the issue of greenhouse gas emissions through carbon sequestration, which is a big word, but it just means trapping carbon in the soil, because not tilling and not plowing the soil allows carbon to seep into the soil and out of the atmosphere, which is really what we need, because right now we have too much carbon in the atmosphere. So if we could get it in the soil, we could really work to fight off global warming. It's estimated that the adoption of regenerative agriculture techniques in the US could offset emissions of about half of the cars in the US. That's a lot of cars. Okay, and finally, we're going to end with a small game of fantastic foods. Try to guess what these foods are, and if you need more time to think about it, don't forget to pause the video. I am known as the meat of the vegetable world. I can be used as a substitute for many different types of meat in plant-based recipes, such as pulled pork. I am different from other plants in that I do not use sunlight to make energy for myself. Some of the most basic parts of me are my gills and cap. What am I? And also to use this as the pulled pork recipe for a plant-based dish, I'll be giving you that recipe in one of the following videos that you'll watch. This is a mushroom. Yes, mushrooms have a very earthy and kind of meaty flavor, and if you actually use the right ones, like oyster mushrooms, you can make them into a pulled pork type of texture. I can be made into a milk, which has a very creamy taste and am an excellent replacement for dairy in many plant-based recipes. I'm filled with B vitamins, enzymes, minerals, and electrolytes. I'm a nut which is grown in tropical areas. I have a hard shell and can float on water, which allows me to float to other islands to germinate there. What am I? Hmm. This one's a coconut. Yes, coconuts are very hydrating and they can be used in a lot of plant-based dishes as kind of a creamy base because coconut milk is very creamy and coconut has a lot of good fats in it. This one is full of manganese and vitamin C. I'm often grown on farms that have hives of bees on it to pollinate me. I'm bright red and very sweet, so a lot of people love to eat me in desserts like pies, cakes, ice cream, and sorbets, or even just by myself. On average, I have about 200 edible seeds on the outside of my skin. What am I? I'm pretty sure a lot of you know this one. It's a strawberry. Yeah, strawberries have a lot of vitamins and they're also super delicious, as I'm sure you all know. This one is a bushy annual plant in the legume family. I am a kind of vegetable and am grown from my circular lens-shaped seeds which are grown in pods. I consist of 26% protein, making myself one of the best plant-based protein sources. I come in all different colors: red, orange, yellow, green, black, and white. What am I? You can also make plant-based meatballs out of this thing. It's a lentil. Yes, you might not know what a lentil is, but they're these small little, almost seed type things which become soft when you cook them and they're really delicious and you can put them in a lot of dishes and season them different ways and they are a great source of plant-based protein. Well, that's all I have for you today. Thank you for listening, and I hope you enjoyed. If you have any questions, feel free to email me at plantedgoodness@gmail.com. You can also visit my website at plantedgoodness.org to find more activities, videos, or recipes, especially if you want to try some plant-based recipes in your own life. You can also learn more about this issue and more about what you can do on that website. Thank you so much for watching today, and I hope you enjoyed. Bye.